Welcome to Just ProTech. Nowadays, when we are implementing services, we usually turn to enterprise frameworks, like for example, the Spring Framework, Quarkus, Ktor, or any other enterprise framework that we can use to take advantage to create our services. These usually follow a typical pattern, which is known as the Model View Controller. And in the Model View Controller, we usually need to implement the controller layer, the service layer, and the data layer. And in the data layer, that is where our services usually start. We define our data very rigorously, then we create our domain model, and with that, we create our repositories, which are then used by our services, which are then used by our controllers. And in between the layer of the service and the controller, we usually use converters. And what I want to say with this is that there are different kinds of segments in our data transmission where a lot of processing occurs. And with a lot of processing means that we need to do a lot of code for it. And another thing that we do when we create our services is to add documentation to them. And for example, if we are using the Spring Framework, many times the way we do the documentation for our services is by the use of Swagger. And to make that happen, we usually just add the OpenAPI libraries. I personally use the OpenAPI libraries in many of my projects on GitHub. And what I usually do, I let the OpenAPI engine generate the documentation for me. That is because my projects are very simple and they are usually focused on one single aspect of what I want to show how it works. But in real life, what we usually have is a manual definition of the OpenAPI. We follow the OpenAPI standards and we create a document that follows our service and explains to us how do we validate the different fields, what types do they have, and what data is allowed to go through so that we can consume those services. I've seen this in banks, I've seen this in telecom companies, and this is something that professionally is done. So there is an extra work done to make sure that we have the right documentation. And when we create the OpenAPI documents, there are two ways of doing it. One is via the annotations, and the other one is via the document itself, creating it from scratch. And we can see already that there are many loops to simply create our service. If we are used to this, we can create these services very quickly to the cost of our own effort. We may not realize, but when we need to create all of this stuff for one single service, we are putting a lot of energy into it. And another thing that happens is that as we go along in the projects usually get more complexity. So that means that in the beginning, when we start a project, the project is very simple. It can evolve very quickly because product knows exactly what it needs. Business can tell us exactly what it needs because business has a very clear idea of what needs to be done in order to achieve certain requirements. But requirements evolve, and they evolve through the years. And I've been already in enough projects to realize that the beginning is very easy, and as we go along, changes can be a real pain to do. Not because there are no tools to make refactoring. We can use IntelliJ or any other IDE to simply refactor our code, and we can just add an extra field, remove that field, add a more complex field to our data model. But it is a lot of work. And another thing that we need to think about is that we may have already created a lot of tests, unit tests or integration tests, chain tests, or even performance and benchmarking tests. And that means that keeping all of our services together can be very complex to keep as we move along. And then we can talk about other strategies, like, for example, microservices. Let's split the service. Let's split it and let's make it smaller. But we are still using lots of different endpoints. We've got an endpoint, for example, for users. We've got an endpoint for a bank account, an endpoint for the address of someone. But these are all different endpoints. And maybe we have endpoints that do certain things, like an endpoint that will give us a simplified information of a user using a certain converter that will just give us those two fields that we need of the user, for example, first name and last name. But then we can make another DTO for another endpoint that will give us the first name, last name, address, city, and another one with the zip code, for example. So that means that at some point, our services that are meant to be simple, where we define the single responsibility very well, they end up not being that simple at all, because we are now creating different endpoints for different payloads. And this can be very difficult to sustain in the long run. And so, wouldn't it be nice to have some way to make documentation easy, to create requests on demand for certain fields, and above all, resourcing to one single endpoint? That is where Apollo comes in. And that is where Apollo for Kotlin made me GraphQL. So let's get into it. Gnothy Soton. I hope I am pronouncing it that correctly. Know thyself. This can be read in the Apollo temple located in Delphi, Greece. And the reason I'm putting it here is so that we understand that before we can talk about the benefits, about GraphQL, and about using services and clients, it is important to know what GraphQL actually is, what our services that use GraphQL are, and what does it mean to create a client with Apollo Kotlin. So what components make up this talk? Well, the first is GraphQL, of course. And as we have said before, GraphQL is a query language. And GraphQL is also a runtime engine. And we will see during our demo, what does this mean to say that GraphQL is a runtime engine? GraphQL was developed by Facebook in 2015, and the idea was to solve the problem of the burden that was to change the data and the data model every time new requirements were coming in. Changing data means changing DTOs, means changing converters, and means also changing the models that are using the application, namely the front end. It also means changing the documentation and possibly the creation of many different endpoints. But Facebook came up with this idea, and we will see the benefits of it. And among them, one of them is that we can extract the data that we actually need. We can make requests that specify in the payload, what do we actually want to get back to the client? A good example is, if we've got a user that has a first name and a surname and an address, we may want to only get the first name and the surname. And we can do that very easily with GraphQL. If we want later on to retrieve the user with the first name, surname, and the address, we can also do that with the same endpoint. Further, GraphQL is not REST. We can technically, and we will see that we can send curl requests to the endpoint that we use for GraphQL. But it's not REST. It has some similarities, but it is a completely different way of handling data. The data doesn't come raw as an input, and it doesn't gets delivered back to the client in a raw form. And what I mean with raw form is that the data that goes into the API that gets used in the interface with GraphQL, it's not just the typical JSON packet that we are used to. With GraphQL, we send also the fields that we want to see and the input parameters and input arguments and the functions that we want to call. And of course, it uses one single endpoint. And by using one single endpoint, we are also saving the effort of creating multiple endpoints, and you can imagine the documentation necessary to specify what every endpoint actually means. So what does GraphQL solves? GraphQL solves the overfetching and underfetching of data. What this means is that if we have an endpoint, well, in GraphQL you have one endpoint. But if you have different functions that return a very extensive object with several different fields, and under those fields you have more fields, you can actually specify in the payload of the request the fields that you want to get. And that overcomes the problem of overfetching. When we talk about underfetching, it's something different. It means that in a regular service implemented with, for example, Spring Boot, because that's what we're talking about in this presentation, Spring Boot, and we have an endpoint that doesn't return enough information because having passed the converter, it only gives us a small set of data. If we want more data to come through the wire and not affect that endpoint, then we need to create another endpoint and the documentation and everything that comes with it. With GraphQL, underfetching is not a problem that actually exists because underfetching and overfetching are easily overcome with the idea of specifying what we want in the payload. And again, the same problem. It solves the idea of having multiple endpoints. But especially when we are talking about one single resource. If you have enough experience with Spring, you have seen that there are multiple services that are implemented in a way that the controller suddenly gets a lot of different GET requests for different kinds of applications, especially in the front end. The front end can, for example, have a dialog that will show some information and the other will show more or less information, or a different kind of information that comes from the same data, from the same domain. GraphQL solves also the constant requirement changes that we get. Another problem that GraphQL solves is the lack of typed contracts. What this means is that when we create a Spring service, for example, with Spring Boot, and we create our controllers, we also define our DTOs. And that means everything that is open to potential clients wanting to consume our services. But we also want to create a documentation for them so that the clients know precisely which kind of data do they need to send and how do they get validated. This is normally done with OpenAPI standards and via the Swagger libraries. When we do that, we have different choices available for us. The OpenAPI can generate the documentation automatically for us. That is also what I do in my private projects. But professionally, we don't get that. Professionally, many times we need to make them manually. But GraphQL does this very gracefully, meaning that we get one single endpoint that we can call and make a full introspection of our services and get those definitions automatically out of the box, and we can generate our clients automatically for us. GraphQL, because of that, solves the inconsistent and redundant potential API documentation that we can generate manually. And the idea is that we don't need to make that much changes at least manually, to our documentation. And when it comes to introspection and knowing what the services do, only one endpoint is necessary. And that was GraphQL. But what is Apollo Kotlin? Apollo Kotlin is a library, a framework that allows us to create clients to be able to communicate with our services. It allows for efficient data fetching. As we have seen before, we can define the fields that we need and the functions we want to call. It can perform complex queries out of the box just by introspection. It has a lot of flexibility because it means that we can perform queries in a way that we can demand our own fields and our own functions to be called and to give us the payloads we need for our services. It is very good when we have evolving APIs. So what that means is if we get different requirements, as we have spoken before, it can evolve very gracefully with those changes without the need for major refactorings in our code. It provides great integration with Spring GraphQL services. The reason for saying this is that by default, Apollo is readily configured to work with these services. That's all it means. It does not mean that it doesn't have great integration for other services like Ktor or Quarkus. But for Spring, it seems to be readily usable out of the box. But there are many configurations that we can use, and therefore Apollo Kotlin is actually ready to use on any kind of service you want to use, especially if it provides support for Kotlin coroutines. So what does Apollo Kotlin solve? It solves the efficient communication between GraphQL APIs. Granted, it is a GraphQL client. It allows for code generation, as we have talked before. This is using the introspection endpoint. It provides type-safe queries and responses. The importance of this is that we create a schema file, and from that schema file, we auto-generate our different entities and our different methods that we can then use to communicate with our services. We might do them manually for the Spring GraphQL service, but not for our client. It also provides optimized caching and offline support. What this means is that when we are accessing a service and for whatever reason the service is down, we can still use the last results we got on our cache for a limited amount of time and be able to retrieve the data that we might need at that point. It provides support for coroutines and asynchronous operations. It provides a flexible networking integration. And what this means is that we can configure things like multiple retries, timeouts, anything that is related to a good communication in a network. That is what also Apollo provides. It provides great error handling. And this is also a given, but it is important to mention that we can handle errors in different ways with the Apollo client. It can be used for server-side, and actually that is where it should be used. We aren't going to do that in our demo. What we are doing is using the client to access directly a Spring GraphQL. And this is to exercise the idea that we are using an interface, a GraphQL interface, when we are using a client. So what that means is that we pick up our client, we communicate with a GraphQL API, and that can be to the service or directly to the database if the database supports GraphQL natively. And it provides, of course, integration with other Apollo tools. And what is Spring GraphQL? Spring GraphQL is a framework that allows us to create services with Spring Boot, but using GraphQL on top of it. So that means we are not creating the typical controller for JSON payloads. We're not implementing a typical REST service. What we are doing is creating a unified API endpoint. What we are doing also with Spring GraphQL is the efficient data fetching with batch loading, if we need it. It provides data fetching flexibility. Again, asking the responses to have a certain form with certain fields, and only the fields that we need. Spring GraphQL works with GraphQL annotations. It is a schema-driven development, so that means that first we create our schema, and then we proceed to make our code. With Spring GraphQL, there is no introspection endpoint yet, and so things are done manually until we get to the Apollo client, where then we can use that introspection endpoint. GraphQL provides a GraphiQL out of the box for testing. And we also have testing tools available in Spring GraphQL. Spring GraphQL also provides security and access control for our applications. It does not mean that we necessarily have to go there in this presentation. In fact, we will not be doing that. But we will have a look at all of the rest of these features provided by Spring GraphQL. And just as before, what does Spring GraphQL actually solve? It solves the problem of overfetching and underfetching of data. Now, we have already discussed that. It consolidates all APIs into a single endpoint. This is true if we want it to be. It is not mandatory, but it can work very well for us, especially if we are working under one specific type in our domain. It improves data fetching efficiency. Of course, if we specify which fields we want to get returned to us when we make certain requests, then that means that we can limit the data that goes through the wire. And that means that we can, using one single endpoint, specify for certain cases how much data do we want. And that is great because then we don't need to maintain multiple different endpoints. It enforces a clear schema for API interactions. This forces us to create first the schema and make the code compatible for the schema. And that means that we are forced to follow a certain standard and we don't have things decoupled, such as is the case, for example, in Swagger. If we don't use the automated Swagger API creation, if we don't see our documentation automatically made for us in our Spring services with the open API libraries, and we do that manually, we can very easily bump into inconsistencies that will show many times during runtime, but not before. And this is something that GraphQL also solves for us. It reduces redundant API calls. As I mentioned before, multiple endpoints for one specific type in our domain and the different converters that are associated to it and the data transfer objects that are also associated to it can be very difficult to maintain. And what further does Spring GraphQL helps us solve? It helps us solve real-time data with subscriptions. What this means is that we are able to create clients using the Websockets protocol. We can keep a connection alive and send and receive data in real time to and from our service. It has great enhanced error management and validation features. Then it has fine-grained access control. It provides us that when we can specify, for example, our fields, as we have said before, but also when it comes to security. It provides an enhancement of developer productivity with tooling, such as GraphiQL, and it provides a smooth integration with the Spring ecosystem. Of course, being at the foundation level still a Spring service, it will surely provide good integration to a Spring ecosystem. And this is where we come to this point, kairos, know the right moment. This is a typical saying, also a Greek typical saying, and it means that we are now looking into the code for our slides. That's what it means. So that means that now we are at the right moment to understand how this works in terms of code and maybe make a sense of all of this information, which I know it's a lot of information for this particular presentation, but it's important to have that present when we are looking at the code. It will be easier for us to relate to what we have just discussed. And to make a good assessment of what we have just discussed and compare it with the code, it is also important to look at the example on a higher level before we go into it with our code. We've got 3 kinds of tests that we are going to do in the demo. One of them is interacting with our GraphQL service with our Apollo client. The other one is interacting with our service with curl requests. And finally, using those interactions with GraphiQL interface. What here we've got represented is the 3 different examples and the requests going through the internet, through the wire. We're doing them locally in this case. And we are accessing our guitar service that is a Spring Boot application with GraphQL as an interface. So this is all that it represents. Meden agan, nothing in access. We can read this apparently in the Apollo temple located in Delphi in Greece. The idea here is that we can request our service the fields that we need. So we can specify our data so that we don't get any excess data. So we don't get nothing in excess. Meden agan. Because now we are looking at the way to program with GraphQL. Namely, to start out with Spring GraphQL. So how do we program it? To start out, we need to set up our guitar service with the right libraries. The first library that we can use is the Spring Boot Starter Webflux, because it makes our application reactive. And if we want to use Kotlin coroutines, this is what we need. It comes with Netty, which allows us to use features that are important to make our application reactive. We also need, of course, the Spring Boot Starter GraphQL. Surely without it, we cannot enable GraphQL. Then we need a Kotlin standard library. We also need Kotlin Reflect. And in combination with the Spring Data Commons, this is what we need to be able to serialize and deserialize data that we then use as entities in our services. We also need Kotlin's coroutine core and Kotlin's coroutines reactor. These 2 are necessary and required if we want to use other features like, for example, Kotlin flows. Then we need to create our guitar service, and to create it, we need to start with the schema GraphQLs. This is a file that we, by default, need to keep in the resources folder of our service, and we define it by using this syntax. This is only a portion of what is possible to do with GraphQL, but this example alone gives us a good oversight in what we want or can do with GraphQL. In this case, we define 2 different entities. One is the guitar DTO and the other one is the owner DTO. These 2 are created as DTOs because the service is a mock service of what a service could be in reality. It is not connected now to a database, simply values that are kept in memory via hash maps. At the top, we see the definition of 2 different functions. And this is important to understand. We define our functions in type query, and there we define what are the types of the input arguments and what are the types of the return values. In this case, we define the input arguments as IDs and the output values as guitar DTO and owner DTO. Important to note is that guitar DTO has an owner field of type owner DTO. This is akin to one-to-one relations in the database. But here we don't have a relational database model. Here we are using GraphQL, which allows us to abstract from those kinds of relations. And therefore, we can define directly our model this way, in a similar way that we would do with JPA repositories, with Spring data. But here is a bit different. After doing this, we can then create our controller. And a controller in GraphQL is slightly different. It is not a REST controller. It is only a controller, and we use it this way. We first define a class to represent our controller, and that class will be annotated with the controller annotation. The methods that we want to use need to be annotated with query mapping. This will allow the mapping between the schema GraphQL's file to the function that is over here. And then we also need to specify the argument, which causes the mapping between this ID and what we saw in the file before. Argument allows that mapping to occur. So then GraphQL knows how to map this function to what we defined in that GraphQL schema. But this is only a simple example. We can further expand our example with a controller that will get our guitar. And as we have seen before, the guitar has an owner, which is located in the field owner. So we define everything normally as we have seen before. We give it a controller annotation and we give it a query mapping in the function that we are using to map to our schema graphs file. But we need to add a schema mapping. And this schema mapping will allow us to give our ID the value of the owner. And what this means, we will see this better in the code, but guitar DTO doesn't have in the code the type of owner DTO for its owner DTO ID. It only has the owner DTO ID, which in this case, it's a long ID. So that's why this schema mapping exists here, because when we make our call, we will get a very complete object, but the mapping will occur over here with the ID of the owner. And this will give us an interface also, which comes out of the box. And as I mentioned before, this is GraphQL. And with GraphQL, we can make requests like this. Here in this example, we are making a request with getGuitar, guitar by ID, and then specifying the fields that we need. And Spring GraphQL will immediately understand this as a request where it needs to return the guitar with its ID, brand, model, and the owner, but which fields from the owner? The ID, the first name, and the last name. These don't need to match with the actual model. If we remove last name, then the server will not return the last name, but it will keep the same structure. Then we need to set up our guitar client. The guitar client basically needs to be in Gradle. It needs the Apollo runtime dependency, and it needs to have its Apollo plugin configured. It's really simple. And here we can see how simple that actually is. We can see that we define the Apollo configuration by giving a name to our service and then setting up the package name where our objects are going to be generated after introspection to the endpoint URL that we give over here. This will allow the compilation of the project of the guitar client to make a call to the introspection endpoint, retrieve the information related to the service, and create the necessary types that we can then use in our code. It will create the functions and the different objects that are necessary. Once it's completed with the retrieval of the schema, it will save it to a place in our object that we can define over here. Now, this is an overview of the two different elements of our architecture, the client and the service. And we can now start with the demo. This animation shows the process of showing how everything works from the service to the client in our project. But we are now having a look at that at a slower pace via IntelliJ in my local machine. So let's get into it. So this is our work environment. The name of the project is called Guitar Shop, and it is available on GitHub, and I will put the links in the description and also at the end of this video. The project is composed of two different modules. One is the Guitar Shop client and the other one is the Guitar Shop service. As we have seen before, for this particular example, it is good that we start with the service. And in the service, we will find the Maven descriptor, which tells us which dependencies are being used in this project. For the Guitar Shop service, I am using a series of dependencies that I have mentioned in the slides, but a couple of new ones to be able to create the WebSocket endpoint so that we can open a subscription for our service. Here we've got the Webflux library, then the GraphQL library, and then we've got the security library, which I will use later on for more examples, but not for this presentation. These two following libraries are very important because they are related to the WebSockets. The first one is the Spring Boot Starter WebSocket, and the second one is the GraphQL Java. We need these two libraries if we want to create WebSockets with GraphQL. The GraphQL Java library is important because it contains classes that are needed to be able to do just that. The next dependency is GraphQL, as we have seen before. We've got the Kotlin standard library, the Kotlin Reflect library, Spring Data Commons, and the Kotlin coroutines libraries, Core and Reactor. And then finally, we've got a lot of different dependencies that are used to create our tests. But the most important ones to create our service are the ones we have just seen. And the first point to start our service, that is our schema file. And that one is located in source, main, resources. And under this resources folder, we can find the GraphQL package, where we then can find our schema GraphQL's file. This file and this location is the default location, as I've mentioned before, where we need to put the first schema for our application. So right over here, we can see exactly the same as we just saw in the slides, but there are a few more things to add. One is a task and the other one is a subscription. We can see already something different here. If we want to create queries, we can use the type query in our schema file. And if we want to create subscriptions, we use the type subscription and create our functions for those subscriptions inside of it. So we can already see that there is something quite interesting and very easy about creating schemas. We just need to define type, the functions that we use, the types of the params, and the types of the return results. In both cases. And the difference is that one is a query and the other one is a subscription. Let's see how this now looks in the code, in our Kotlin code. We can see our guitar application launcher, and here we see that this is a Spring Boot application not very different than what we are used to seeing in Spring Boot applications. Right over here, we've got our controllers, configuration files, DTOs, repositories, and services. But let's start from the beginning, from the domain. In our domain model, we can find different types. We can find a guitar type, an owner type, a task type, and the repositories. The guitar type, we can see already that it is very similar to what we see in our schema. It is a match, because what we find here in GraphQLs needs to match what we see in our code. So we've got the domain here with an ID, which is long in our code, but it is a generic type in guitar DTO. We've got a brand, a model, and a year, and the owner. In our domain model, we've got a brand, a model, a year, and an owner. And in this case, owner is of type owner. And then we've got the repositories, which are simulations of a real JPA repository. So these are just manually made, and they just return the values that are contained in these lists. And to implement a find by ID or null, just simply use a first or null and use a filter on it, and with find all, we just return all of the guitars that are located over here. And this is for the guitar repository, and this is for the owner repository, where we can find the list of all the users that are owners of the guitars. But this is in the domain layer. The DTO layer is the one that we have implemented with our schemas. This is the one that we want to have. And here we do something slightly different. The guitar DTO is now a simpler type that contains an owner ID instead of an owner. And the owner DTO has simple information about it, similar to what we saw in the domain. And the to DTO, we can see here that it converts a guitar, which is in the domain layer, to the DTO layer with the ID of the owner. And the same goes to owner, although in this case it's a one-to-one match. So now we know that guitar DTO and owner DTO contain information strictly related to them, but they're not bound to each other. In fact, they have been unbound from the domain. Well, but let's abstract for a moment from all of that, from all of the domain, because that was done simply to simplify the model and to make a mock-up of what we would find between the API layer, the GraphQL API layer, and the database. What we are interested here is in these DTOs. So if we go back to our service, we see that it starts a Spring Boot application. So that means that controllers is something that it will see and it will interpret and it will make available, but not in the regular way that we are used to with REST services. In this case, controller is what we saw in the slides. We've got our controller with our mapped method, with our input parameter, and the return value. The same goes to the guitar controller. But we've got another one, which is the task subscription controller. And this one is different, because this one uses a service in between to get task updates. And get task updates is a flux, is a call to a function that returns a flux, and for every second it fetches the last task. Now the last task is also a mockup, and what we do to see that it fetches the latest task and to see a change in the return results is just to add a random value to this ID. So the ID will be always, hopefully, a new value for every time we get a value from the service, and that is for every single second. One important thing about the guitar controller is that when we get the guitar via the service, we are getting the DTO. And getting the DTO means that we lose the information of the owner, because we will only have the owner ID from the DTO. So how does GraphQL fill this in for us? As we have seen in the slides, it uses the schema mapping to achieve this. And how it achieves that is that it calls this owner right over here to get the data from the owner of the guitar. And this owner method needs to have the same name that we defined in the schema right over here, schema GraphQLs. And here we can see that owner is the name we give to the field for the guitar DTO. Now this is important because what we return is not the DTO itself. What we return is the construction that GraphQL is going to make from all of these mappings. And that construction is defined in the schema GraphQL's file right over here. So what GraphQL is going to return is whatever we put here. But whatever we put here can mean functions or can mean fields. For GraphQL, for the payload, it means just fields. But for our code, owner in this case means a method that will get our owner from the guitar. So when we call this, before it returns the value back to the client, it will search the owner field by using the guitar DTO itself so that we can get the ID and then return the owner completely for the field owner by the return value of the owner service. And that's how we get the full information of one guitar. Possibly, because we can then change this. But let's see how this works to make it really clear. So let's just start our guitar application. It has started already, so we can see that it's open on port 8080. In the README file, you will find links that are very important to make sure that we get to the right place when we are testing this. For the GraphiQL page, we can just open the link on the README file. As we open the page, we see that there is already one example for us with the subscription update. Let's first look at the subscription to see how this actually works in terms of making subscriptions with Spring GraphQL. Let's run it. And what we see now is that there is a connection made to the service, and we see that the IDs are already changing every second to a new ID. And this is the establishment of a WebSocket connection. And we can see also that the GraphQL interface that is given to us out of the box by Spring GraphQL has a stop button initialized. So if we stop it, then we are breaking the connection to the WebSocket. What we can also do is actually the traditional requests, which we can find in the README file over here. So for example, if we want to get the guitar with ID number 1, then we can just start like this and we will get the guitar. We'll get the Fender guitar, the model Stratocaster HSS Tidepool MN. And we see that the owner is me. I don't have this guitar. But in the example, I do have this guitar. We can check who is the owner of guitar number 2. In this case, is the owner called Betty L. And guitar number 3, then it will be my guitar. Alright, but what about if I just want to get the brand and not the model? Then I just ask in the same way the guitar via the method guitar by ID, what we have seen before in the code, with ID number 3, and I'm going to ask all of these parameters. And by the way, I don't want the ID. So let's take the ID out. If I make the request like this, then the payload that I get back is just the brand and the owner. But wait, I don't want this ID as well. So why don't I just do this? There. So I have the guitar. I know that owner, João Esperancinha, has the brand Gibson, and that's it. I don't know anything else because in my request I didn't specify it. I can also say, just get me the brand of guitar ID with just get me the brand of guitar with ID number 3. There, it's Gibson. That's it. I don't need anything else. Of guitar number 1, Fender. Guitar number 2, Jackson. So we can play around with these fields and ask precisely what we want from the database. And we can also do something else. We can just simply get the owner, for example. So if we say get owner, then we see that owner number 1 is me with this last name. But we might just want to say that we want the owner with the first name and last name. So in this case, I will get just that, an owner with the first name and last name. It's interesting. How can we configure this? So we have started from more complicated to more simple. We were able to create a subscription which was already made available to us, but that was only with the history. What we can do is go over here and say, we want to add a subscription. Now we've got the subscription here, but it's not the one that we want yet. This is only a placeholder. We can fill in this placeholder by going over here and selecting the one we want. At this moment, we only have one method that we can use to make a subscription to. If we click on it, then we've got the task updates filled up for us. What we now can do is request for the ID of the task. And we can just say we want project, whatever project we want. Project 1000, for example. And if we start it, then we get only the ID for every element that is sent out via WebSockets to our local client in our machine via the web browser. All right, so this is a quick example of a GraphQL, and in this case, GraphiQL. Let's now try and do this in the same way with a curl request. And I've got one right over here in the README file again. And we can see it over here. Let's just look at one, for example. If we now use this one, we copy this and we go to our command line and we run this over here. We should first read what we are about to run. We are running a post request to the GraphQL. This is just a typical post request to an endpoint that can interpret JSON requests. Our query is sent into a package with a JSON format. And if we send it this way, just like we sent it in GraphQL, then we will get our answer. And in this case, we get our data inside the data field with everything that we requested. And everything is done by establishing a hierarchy of data, the name of the method that we are calling, and then all of the data related to what we wanted to get from the service. In this case, the ID, the brand, the model, the owner, and the first and last name of the owner, along with its ID. So now we were able to communicate with GraphQL using a web browser and GraphiQL. We were able to do that as well with a curl request. But now this is the best part. How about doing that with Apollo Kotlin? With Apollo Kotlin, we can indeed create a client, and that is what we are doing over here in the Guitar Shop client. Now, the Guitar Shop client doesn't have an extensive code. It actually is a very simple application. As we have seen in the slides, we first need to give it the runtime of the Apollo, like this. Then we need to configure our Apollo service with this configuration over here, just as we have seen in the slides, with the endpoint, the schema file, and specifying the package where we want our classes to be dumped in. And our code is very simple. Once we've got all of that created for us, then we just need to call our functions, just like this. So we create an Apollo client. This Apollo client is created for us, and this Apollo client has already the methods that we need to use in order to get our data. In this case, the guitar list query is one of them. But let's see how this actually works from the beginning. In the beginning, the first thing we need to do is to create the entities that are necessary to run this. And they will be created here in this build folder, in the typical build folder of Gradle, and they will be found over here in the generated package over here, and we will find all our code generated here in Kotlin. One important thing. The way to run this is to go to our client folder, and then here we need to run a specific command that Gradle provides us with the Apollo plugin. So we can go right over here to the root of the Guitar Shop client, and then here we can run one command, and that is the introspect command. Now this I've made with a makefile, but what we need to do, we need to call this task over here, download service Apollo schema from introspection. If we run this, I will show you an example, because this example is already ready for us to test the client, but I will show exactly how this works now. So if I remove the schema GraphQL's file, then I only have this file. I will explain now what that is for. And I do a Gradle download service Apollo schema from introspection. It will now connect to the running service that we've got over here running on port 8080, and it will get that schema file, it will introspect it, and it will return an interpretation of the services. So as we can see here, it is not exactly what we have created in the Spring GraphQL service. It has a lot of things that are added to it as a result of the introspection. But we need to do one more thing. We need to wrap whatever we want to use out of this schema into a separate query object. For example, here we are wrapping guitar by ID. If we do this, it will create the necessary objects for guitar alone. So if we now build our project having this GraphQL file here, which is a separate file from the GraphQL's schema, then we will be able to create the code that we need to be able to create our client. If we just use a make on the root of this project, it will now call this script over here, which will just build our project. And doing that means that we've got all our dependencies here in the build folder. Over here, as we have seen before, what I want to show is that we've got the guitar list query over here, but we shouldn't find anything related to our subscription service. And if we run the client the way it is implemented right now, using Kotlin coroutines, which is this one over here. So we are starting this test using a run blocking with dispatches IO. And then here we make 3 different calls from that coroutine to a suspend function, which is this one, find and echo guitar information with this ID. And then we call directly the generated method that has been created for us, this guitar list query, with an optional ID. And when we run this code, we will find that the result from making this call to our service will give us back all of the guitars with the respective owners in them. So we've got the first one with my name on it, the second one with Betty, and the third one with me. But this is the simple part. Let's try and do the other one. Let's try and do the WebSockets client. For that, let's see what we can do. We've got here the ability to create a wrap-up file. So let's say we'll call this task list GraphQL. And then here, unfortunately, when I ran this example, which is the completed example of how you would get the subscription by calling subscription and then defining our subscription over here and then calling execute, just like when we get the guitar details, calling the guitar object, sending in the ID that we need, and then finally executing it. The problem here is that apparently, when it comes to Apollo, it doesn't seem to support subscriptions anymore since version 3. I am now using, let's have a look at the version that I'm using for Apollo. I'm using version 4.1.0. So apparently we can't do that, and it is very clear in the Spring Boot application, the one that we have used with the Spring Apollo libraries. It says that Apollo Graph Subscriptions Transport WS is not supported nor maintained. It does, however, suggest an alternative, and it's this one, GraphQL WS, which is for Node.js. And this library would be something that can communicate with the WebSockets in our Spring GraphQL service. It would have been interesting to have this working, but at this point it's something that it's not particularly related to Apollo, and Apollo was the subject of this presentation. So we have seen interesting things about the project Apollo. We can create simple requests with it. We can change our requests as we want with the definition that we create with our schema GraphQL files, and we can use this to create clients very easily with Apollo Kotlin. The code gets generated in Kotlin, and we can use it very easily by simply invoking what we need to get the data that we are interested in from our service. And we can also select the data that we need from our service. Just like over here, I'm making a call to get the guitar, and then I select the data that interests me, because I have selected in the schema, for example, in the guitar list, that I want the complete information of the guitar. When I invoke this guitar by ID, the one that we see over here, the guitar list query, then I am supposed to get the ID, the brand, the model, the year, the owner, the ID of the owner, first name and last name, which makes the creation of the Apollo client, the documentation of it, introspection, and the maintenance of the whole project much easier than just using a REST application with Swagger. which means that now we can create both a service with Spring GraphQL and a client with Apollo Kotlin. The only drawback is that they have indeed dropped the support for WebSockets. And apparently, as far as I could gather, it has to do with the complexity that Apollo client was having in the code base that was being used. But we are several versions ahead from the time where WebSockets were removed from the framework of the Apollo client. So now let's wrap up our presentation. Let's go back to the slides and see what else can we say about Apollo Kotlin. What questions can we have about this? So now it's the time to look back at what we've done so far, the theory, and what we have achieved here. We have achieved a service. We created a service that opens an API, which is a GraphQL API. It provides a query language where we can use to retrieve data from our database, customized with only the fields that we need. We've created a client that can use the introspection endpoints to create the different code that we find necessary to use in our application. And with this, we can extrapolate the further uses that we can give to this in an actual situation. In an actual situation, we would need to present an API with GraphQL. It would be open publicly with an introspection endpoint, and the service itself would probably use Apollo in its constructions inside of it, maybe even as a repository or a data access object, so that we could get, using the Apollo client, the data that comes from the other databases. This data would be coming from databases that support or provide an interface with the GraphQL format. And we have also seen that it isn't just GraphQL that is a graph database. There are several others. One example of that is Neo4j, which is also another kind of database. Sometimes it's associated, due to Project Apollo, with GraphQL. But it really is not a GraphQL database. It is a graph database. What do I think of using GraphQL? I think it's a great idea. I think that the idea of creating and maintaining the documentation and providing that documentation to potential consumers of our services can be quite a lot of work, especially when we are trying to get everything to work correctly and we find that there's a mismatch between the documentation we provide with the open API and the actual features that the code provides. You can find resources about this presentation right over here. This is what I've used to create it. There's a lot more resources also available to see that I put on GitHub. In the repository, there's a list in all of the README files of places and books where I have researched to make this project and this video. The source code is located on GitHub on this link over here. The name of the project is Guitar Shop under my username, J. Esperansinha. You can find me on my homepage with that huge name, joaophilipesabinho.nl. You can find me on Threads, on LinkedIn, of course on YouTube, this channel, or perhaps if you are watching this in Daily Motion. You can find me on Blue Sky, Mastodon, GitHub, HackerNoon, DevTO, and Medium. And finally, I would like to thank you for watching this video. I sincerely hope that you have learn something that you didn't learn before. If you already knew about GraphQL and want to send a comment over this video, I really appreciate that. If you have learned something, I would love to see you sharing what you have learned with this video. If you've got some points where you think that you probably missed something that I could incorporate in the next video, please let me know in the comments. Don't forget to drop a like to this video. Don't forget to subscribe so that you don't miss out on new videos that I will be posting here. There are always new videos coming into this channel. And do not forget to read the description because it contains essential information about this project, the video, and further documentation that you may require to understand more about this project. The slides will be available on Scribd and on SlideShare. There may be differences in the slides because I am limited in terms of size to the content of the slides. And until the next video, have a good one. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.